evening, everyone.
Good evening.
So today I'll be your chairperson. My name is NADHIRAH binti ABDUL HAMID, matrix number 186861. For today's discussion, we'll be talking about genetic diseases associated with the failure of metabolic pathway. In this case, we'll be talking about beta mannosidosis in cattle. So before that, I will let you guys introduce yourselves, starting from my right.
Okay, hi, my name is FARHANAH and ABIDIN, and my matrix number is 190181.
Hi, my name is SYAMIRA, and my matrix number is 190274.
Hello, my name is NURUL AQILAH binti MOHAMAD, and my matrix number is 190507.
Hello everyone, my name is Tan Iwan and my matrix number is 189724.
Hello everyone, my name is ATIFA binti APANDI and my matric number is 189744.
Hello everyone, my name is Yang and my matric number is 188722.
Hi everyone, my name is NOOR AQILAH binti ANNUAR. My matric number is 187312.
Hi everyone, good evening. My name is SHARLINA binti SHARIZAL AZUAR, matrix number 189824.
Hi everyone, my name is SYAZWANI binti LOKMAN, my matrix number 190197.
Okay, so what is beta mannosidosis? Beta mannosidosis is a metabolic disease whereby an accumulation or storage of specific lysosomal enzymes, substrates, or byproducts occur within cells. It is a rare genetic condition where an animal has partial or complete deficiency of beta mannosidase enzyme. So this disease is especially prominent in sailor cattle, which is a breed of cattle. It causes recumbency and cerebellar signs in sailor calves as well as newborn Nubian goats. So, next question.
I will talk about the objective of this discussion. Firstly, it is to determine the storage disease in animals. Second, it is to determine the causes of storage diseases in animals. Lastly, it is to determine the effects of storage diseases in animals.
Okay, so I will continue from here. As NADHIRAH has said earlier, beta mannosidosis is actually one of four main lysosomal storage disorders that you can find in animals. So, as she has also mentioned, and for the sake of today's discussion, we will be focusing on beta mannosidosis in sailors' cattle because this only affects sailors' cattle. So, what happens is beta mannosidosis is actually the result of a deficiency of beta mannosidosis, which is one of the enzymes in the oligosaccharide catabolism in the animal. So, actually you can see from this diagram here, this is the catabolism of oligosaccharides. And as I've highlighted in this last picture, this is actually one of the last stages of oligosaccharide catabolism, where beta mannosidosis is going to cleave the beta-linked mannose residue in the N-glycosyl protein glycans, which is this substrate here. So when there is a lack of beta mannosidosis, what happens is the pathway is blocked. So we have an accumulation of incompletely graded oligosaccharides. And such examples of oligosaccharides are manganese beta 1,2,4-glycosidic natrium accumulate, and there are four types of oligosaccharides that can be accumulated in the cattle itself. So basically these oligosaccharides, they do not completely degrade, or they are either spliced mutantly, meaning they are spliced at the wrong area. So what will happen is the gene itself will then become a defective gene because there is an extra nucleotide in half of the gene and there's a lack of a nucleotide in the other half. So Basically, what happens is after the accumulation of oligosaccharides in the cattle increases to a level where it's degrading for the cattle's health, that is when the beta-mannose sickness starts to kick in. So that is all for me.
So I would like to add up a little bit about the symptoms of this disorder. So there are two basically main symptoms, which are recumbency and also ataxia. So recumbency means the cattle or the calf can't stand properly. This is because of their joints, which has this their joints did not grow properly, and this recumbency also tends to have this calf also tends to have tremors. And the second one is ataxia, which means the loss of body control. So this calf will have this dome cranial part, which is the cranial part will curve shape, and this is made due to the growth of the brain, or the abnormal growth of the brain. So both of these symptoms actually is observed by the scientists or veterinarians based on a few cases that is appeared from the cellular's brain. So, even you would like to add?
Yes, we continue to talk about the diagnosis, treatment, and prognosis of beta-mannosidosis in cattle. So, beta-mannosidase deficiency results in beta-mannosidosis, a severe neurodegenerative lysosomal storage disease identified in cattle, goats, and humans. And beta-mannosidosis diagnosis can only be done by polymerase chain reaction assay by sampling of suspected cattle. To more fully understand the molecular pathology of this disease, the mutation associated with bovine beta-mannosidosis was identified by a sequence of analysis of complementary DNA from an affected calf. So, a transition mutation of guanine to adenine at position of the complementary DNA coding sequence create a premature stop codon near the third end of the protein coding region. So, to aid the commercial breeders of Salers cattle, a PCR-based test was developed to detect the mutation for beta-mannosidosis carrier screening. So, application of this test also revealed the presence of two beta-mannosidase pseudogenes. So, a portion of the pseudogenes were amplified with allele-specific primers and the sequence. One pseudogene was highly homologous to the express complementary DNA sequence over the base pair that were sequenced, while the others showed more divergence in the base pair that were sequenced. Both are processed pseudogenes that are not expressed. The severity of the phenotype suggests that the 22C terminal amino acid of beta-mannosidase play an important role in the function of this enzyme, and that unfortunately there is no specific treatment for affected cattle. However, crossbreeding in commercial beef production have helped reduce the significance of these recessive defects, and the prognosis of this disease is poor as present severe neurological deficiency that will lead to a rapid neonatal death. So that's all for me.
So I will continue about abdominal thyroid structure and function in a lysosomal storage disease. In beta-mannosidosis, the thyroid in the affected newborn shows marked cytoplasmic vacuolation. There is an associated reduction in the serum concentrations of thyroxine and 3-iodothyronine. Thyroxine is important since its broad functions is to control the rate of metabolism of the body. Thus, a decreased level of thyroxine results in a lower metabolic rate. 3-iodothyronine, also known as T3, is a thyroid hormone. It affects almost every physiological process in the body, including growth and development, metabolism, body temperature, and heart rate. Severe thyroid morphologic abnormalities found in a previous microscopic survey of tissues from neonatal affected animals suggested the possibility of impairment of functions. Since considerable evidence indicates that thyroid hormone plays an important role in regulation of myelination, thyroid hormone deficiency, if present during central nervous system development, could be a factor in the hypomyelination seen in affected animals. Major findings in thyroids from affected animals as early as 96/150 days gestation included follicle irregularities and pronounced presence of lysosomal storage vacuoles in all cell types, particularly in follicular cells. The degree of cytoplasmic vacuolation increased with advancing stage. Significantly decreased thyroid hormone concentration were present in affected animals. It is hypothesized that thyroid hormone deficiency plays a role in the pathogenesis or hypomyelination in affected animals.
So next I will be talking about oligosaccharide. So basically, beta mannosidosis, also called lysosomal beta mannosides deficiency, is a disorder of oligosaccharide catabolism caused by decreased activity of enzyme beta mannosides. So different oligosaccharides consisting of a number of disaccharide and other more complex oligosaccharides that will accumulate in the tissues and the kidney of the affected animals. A storage disease characterized by widespread population of cells throughout the body was diagnosed in a newborn calf of the seller's breed, extraction and analysis of water-soluble material showed that storage material was oligosaccharide in nature and was probably derived from the core region of the heterosaccharide moiety of glycoproteins. Glycosides analysis shows that the disease was due to the deficiency of acidic beta mannosides. Ruminants affected by the disease present severe neurological deficiencies associated with myelin abnormalities and lead to the rapid growth, rapid death. Urine testing to identify abnormal oligosaccharide is a useful screening test, and enzymatic analysis or molecular testing can be used for confirmation. So for me.
So now we're talking about the importance of oligosaccharides. We all not really understand what is oligosaccharide. So there is which we call it as monooligosaccharide or MOS, is a nutritional supplement which is widely used in nutrition as a natural additive. So this MOS or the monooligosaccharide is known to improve the gastrointestinal health of the overall health, and thus improve the well-being, the energy levels, and the performance of living organisms. So most in MOS products actually, it has particularly used with scientifically review derived from cell of the yeast, which we call as Saccharomyces cerevisiae. And I will give you an example in cow, MOS for cow. So this oligosaccharide it has been reported that in a young bull cows where they have noted that they are improved in the intake and subsequently better growth rate because of the feeding of oligosaccharide. And the health status of the young calves is one of the most important factors contributing to growth and performance. So diarrhea in young calves is a major issue in dairy sector. So this MOS cause the viral or the bacteria which cause the diarrhea, we known as E. coli. When the MOS bind with the E. coli, and it can modify and improve the composition of the intestinal microflora, resulted in a reduction in fecal fecal E. coli counts and improvement in fecal score in cows with mouse. This improvement were coupled with an increase in concentrate driving immunity and better performance. In addition to the changes in gut, several authors have also noticed the improvement in respiratory health and also contribute to better performance. And there are reports that show that there is no effect on light weight gain despite increased feed intake. So whenever they feed these oligosaccharide, there are no light weight gain. And then it's similar to the gain of use of antibiotic, where it has been achieved that the following supplementation of meat replaces with MOS. So this very coffee MOS has better immune protection against rotavirus and able to pass some of the protection onto their calves when they give birth. And the transfer of immunity from the cow to the calf is critical in order to protect the calf from many different diseases. So that's all.
So, while reading about the topic for the discussion today, I have discovered quite a few scientific terms that have been actually mentioned quite a few times during discussion. So, I would like to explain more about the terms. For the first term, which is Mannosidosis, is a rare genetic lysosomal storage disease of cattle worldwide. So, for this discussion, we'll be talking about beta Mannosidosis, which primarily occurs in Sala cattle. In Sala cattle affected by beta Mannosidosis, calves shows signs of recumbency and ataxia. So recumbency is a clinical term which is used to describe an animal that is lying down and unable to rise up again. So recumbency in cattle is caused by numerous metabolic, traumatic, infectious, degenerative, and toxic disorders. Like in this case, is due to lack of beta Mannosidosis. And for the next sign, ataxia, which is lack of muscle coordination, which may affect speech, eye movements, and the ability to swallow, walk, pick up objects, and other voluntary movements. So another two terms that I learned more through this reading about this topic is neurodegenerative disease. So neurodegenerative disease is an umbrella term or a collective term for a range of conditions which primarily affect the neurons in the human brain. So neurons are the building blocks of the nervous system, which includes the brain and spinal cord. And the last term would be lysosomal storage disease, which are a group of approximately 50 rare inherited metabolic disorders that result from defects in the lysosomal function. So lysosomes are sets of enzymes within cells that digest large molecules and pass the fragments onto other parts of the cell for recycling. That's all for me.
So I would like to conclude from our discussion just now. Since the objectives are to determine the storage diseases, to determine the causes of the storage diseases in animals, and to determine the effect of the storage diseases in animals. From the first objective, we already achieved, which is to determine the storage diseases in animals, which is from our discussion, I could conclude that the storage diseases that commonly occur in cattle is beta Mannosidosis diseases, which is commonly occur in Sala cattle. The next objective is the causes which causes the storage diseases in animal, which is it is caused by the deficiency in beta Mannosidosis enzyme, which is an enzyme which helps in oligosaccharide catabolism. And the last is the effect of these storage diseases in animal. From our discussion just now, I will conclude that the effect of these storage diseases are ruminants affected by the disease present severe neurological deficiency associated with myelin abnormalities and lead to a rapid death.
Okay. Alright, thank you everyone for your contribution to this discussion. I think that it is really important for us to know a little bit about this topic, as it might come in hand for us in the future. So I hope everyone listened well and has learned a thing or two about beta Mannosidosis in cattle. I guess that is all for today. Thank you.
Thank you.
Yay!
Yay!